Thank you, Pete. So as Pete mentioned, I'm going to be talking about the next phase of the Caspar Creek experiments, which we're calling phase 3. And we're going to look at the reduction of the canopy on different watershed processes. And again, this is a joint effort between the Forest Service, I'm with the Pacific Southwest Research Station, and with CAL FIRE. Just on here, there we go. So planning for this effort began actually a while ago in the late 1990s. And flumes were installed in the South Fork Caspar Creek tributaries in 2000. And so you'll notice that it's now 2015. There have been retirements, there have been budget cuts, so forth. So the project has been delayed, much to my benefit, because I came on in March, and we sort of revitalized the effort to get phase 3 off the ground and running. The advantage to this from a scientific standpoint is that we now have 15 plus years of pre-treatment stream flow, sediment, turbidity data, which is pretty unprecedented for forest hydrology studies. So as Pete mentioned, the South Fork Caspar Creek is 424 hectares in size. That's at the weir of the South Fork Caspar, and has 10 sub-watersheds in it that really range in size and watershed characteristics. So just back to this map, do we have a pointer on here? There we go. So you'll see we actually have 9 flumes instead of 10. Q right here is sort of the matrix in between all the other sub-watersheds. It's not gauged, but we do figure out discharge using subtraction. Then I also wanted to point out Yoakum right here. Yoakum is a nested watershed, so it's downstream of Zemer, which allows us to look at some of the cumulative watershed effects of forest management in Zemer. So as Pete just mentioned, the first and second experiments were sort of more of your traditional forest hydrology experiments, and they looked at harvesting effects on stream flow and sediment. And then in the second experiment, looking at cumulative watershed effects. There were some process-based studies as side projects of those experiments, but for the most part, they were really looking at landscape level effects. So for the third phase, we wanted to dive in deeper and see what's actually happening with some of these watershed processes. So our goal is to investigate the effects of canopy reduction on biogeochemical watershed processes in the South Fork Caspar. So one thing that's really interesting about this experiment is in traditional forest hydrology studies, we quantify a harvest in terms of basal area. It's what foresters know, it's what we like, and it's really conceptual. You can actually imagine the area or the volume of wood that's out on the forest. But when you think about what's happening in these watersheds, a lot of the processes are being driven by light itself. So regeneration, all of the stand dynamics, it's all these trees competing for light. And it's also really driving the water cycle, evaporation, decomposition. We could go on and come up with the things that light's influencing. So we wanted to tie back these watershed processes to the actual light and then help inform management. So we're working, one of the reasons we don't use leaf area is because basal area is much easier to measure. We can go out and measure the diameter of trees. But we're working with Kevin O'Hara at UC Berkeley and some of his grad students, and they're developing equations for us that allow us to predict leaf area from basal area and height measurements. So our study design is also a little bit different than your paired watershed study. We're using a regression-based sampling design. So we're actually going to harvest or reduce the canopy along a gradient of treatments. So our lowest level right here is the 25%, and that's a pretty light touch. Anything under that, we wouldn't expect to see any real effect on the ecosystem. And then at our highest level, we're going up to 75% reduction, and this is going to hit the watersheds pretty hard. To most people, it might look like a clear cut by the time we're said and done. And I wanted to say that we used this regression-based design so we can hopefully identify the threshold at which these different processes are responding to canopy reduction. So back to the map, you can see we have our watersheds determined. We have the low range, 25%, and the high range up here at 75%. We also have 2 control watersheds that we're setting aside. We have Rick and Will right here. And those, we're planning on having those be control watersheds to the end of the agreement, 2099 that is. So that'll allow us to look at some of the long-term effects, the stability of these ecosystems over time, hopefully how they respond to Godzilla, El Nino that's coming, apparently. And the other thing that's not, Yoakum also is a no treatment watershed, but remember that that's downstream from Zemer, so we'll be able to look at the effects of hitting Zemer really, really hard and what is that doing to the main stem of Caspar Creek. Q right here, our matrix in between, we are planning on harvesting in. That's at the discretion of CAL FIRE, and last I heard, I think it's going to be about a 35% reduction in the canopy. And this is so I don't forget, we're harvesting, we're planning on spring of 2017 to start the harvest, and then we'll move through the watershed, and we're anticipating that it'll be done in 2018. So I just wanted to briefly talk about all of the different studies that we have planned. We're doing a lot. The first one is just continuing the long-term studies that CAL FIRE has been, or PSW also, have been doing. And so what are the immediate and long-term impacts of reducing the canopy on stream flow and sediments? So we'll be able to look at what's happening right after the harvest and then into the future. The next are the plant water use studies. These are my bread and butter. I'm really excited about these. And this is where we're going to look at actually what's happening to the water budget in the ecosystem following the canopy reduction. So we're currently, not we, I'm down here talking to you guys, but there's a field crew out there digging really hard to put in piezometers. Not fun to do during a dry season. They aren't getting any water. Putting in soil moisture measurements, lots of sap flow right here, which will allow us to look at evapotranspiration. So we'll be able to see what the residual tree water use is. So what's actually happening to the evapotranspiration of the trees that are left on the ground. And as part of this, we're also looking at the source water of this vegetation. So if you have a tree you've removed all of its competition, is it then going to start pulling water from more readily available sources, say precipitation and fog, more than deeper groundwater? And we're doing this using stable isotopes. So as Pete mentioned, one of the great things about Caspar is it has a really long-term sediment budget or sediment record, and I think it's one of the oldest that I know about. I don't know of any older records of sediment. And one of the cool things that we can do now is actually use chemical fingerprints to figure out where the sediment in the stream is coming from. So is the sediment in the stream coming from the hill slope, from the road building, the actual harvesting practices? Or is it because we actually increased the discharge in the stream channel and the water is scouring out the sides of that bed? And then how do those sources change as we move along that continuum of canopy reduction? So that was just a few. We're also doing some channel migration, looking at ecosystem resilience with lots of different vegetation measurements. And then we can run an economic and ecological cost-benefit analysis of harvesting at low levels and then maybe re-entering later or harvesting at high levels. And you'll probably notice that I'm missing the aquatic system, right? Very important. So we've been working with Jim to develop the swamp framework for use in Caspar Creek. And we'll be collecting a lot of different data at the tributaries and as well as along the main stem of Caspar South Fork. But the problem is we can't do this alone. So if there are any grad students out there, any PIs, we need help. This is, yes, please help. We're going to be collecting a lot of data. We would love more research questions involved with this. So please, if you're interested or if you have any other research ideas, feel free to contact me. My number and my email are down here. I'm located just across I-80 here in Davis, so happy to meet with anybody. We'd love to put maybe UC Davis on that list of collaborators, so please, please help. And with that, questions for Peter, if we have time?
Thanks. Can you actually just talk a little more about the sediment fingerprinting you're going to do, how that works?
Yeah, we're working with people at Oregon State on that, and they've proposed a few different things. You can use lead, I know you can use cesium, and basically the in-channel sediments have a different signature than the hill slope sediments. And so if you know those two sources and then you can pull out the sediment that's in the stream channel, you can then discern where it's coming from. It's a really, really simple way of explaining a very complicated process.
So you're not spiking the hill slope
No,
sediment?
no, it's not a tracer study.
Okay.
Those are naturally occurring elements.
Has been used successfully in the Midwest.
Yeah, it's been used out at the University of Minnesota. They figured out that the sediments in the Mississippi River were actually not coming from the ag practices, but actually the tile drainage was increasing the stream flow and then causing in-channel erosion. So pretty cool stuff.
One more quick one. So for the bioassessment, do you need bodies? Wait a minute, we got to record it.
I think I heard, do we need bodies or
Money.
money?
Oh.
Yeah, both. We do have some bodies. We hopefully have some money, but the big part is going to be some of the data analysis. We'll need help with that. So.
Like for example, the proposal I gave them for the invertebrates or the swamp protocol had us doing the full swamp protocol or trying to train students to do it and have an ongoing team that way. And then incorporate audits and stuff. So it depends on, I think it's a good opportunity. Hopefully like North Coast Board might be interested, anyone who wants to get involved because it's an experiment and we could actually test some of our swamp protocols on doing it. It was Pete who asked us to get involved and I think it's a good opportunity. It's just like anything, money. Money in it when they need the help. Well, thank you.
Thanks.
And you could contact any one of us if you're interested in getting involved.